Hello, this is Carl from roboton-io. Today I will teach you how to make your self-driving car finish the track with as little code as possible. To do this, we will use one of the simplest concepts in control theory, called a proportional controller or P controller. But first, let's take a look at our design environment. On the left-hand side, we have the simulation of the race car on the track, and on the right-hand side, we need to write the control function that will control the race car. The skeleton of the control function is already present. The function will be running 60 times per second, and each of these times it will get the current sensor values and output the controls to the car. It's up to us to write the control function so that the car follows the black line of the track and goes through all the gates. The time it takes to complete a lap is recorded, and of course we want to go as fast as possible. As sensor inputs, we get the values of the left and right ground sensor and the current speed of the car. When we look at the front of our race car, we see the two ground sensors in blue. They look straight down on the track and output a value that indicates how wide the ground below the sensor is. When the sensor outputs 1, this means that the surface below the sensor is completely white. And when the sensor outputs 0, this means the surface below the sensor is completely black. Currently, the sensors indicate 0.06 and 0.13. This indicates they see a lot of black with a little white on the side. As controls to the car, we need to output 3 values: the engine torque, or how deep we push the throttle, the braking torque, or how hard we push the brakes, and the steering angle, or how much we turn the steering wheel left or right. Let's make the car move by outputting an engine torque of 1000 Newton meters. As you can see, the car simply accelerates straight until it falls off the track. Now let's turn the steering wheel a bit by setting the steering angle to 0.3 and see what happens. As you can see, the car turns to the left. If we change the steering angle to minus 0.3 and restart our practice run, we see that the car turns the same amount but now to the right. So positive steering angles make the car turn to the left, and negative steering angles make the car turn to the right. Now that we know all this, we can start designing a control function that steers the car so that it follows the black line through all the gates. Let's imagine that we are driving on the track and our car ends up slightly to the right of the track. In this case, the surface below the right sensor will be more white, and thus the right sensor will output a larger value. Actually, the more we move to the right, the larger the right sensor value will be. The opposite is of course true if our car moves slightly to the left of the track. In that case, the left sensor value will become larger. If we now subtract the left sensor value from the right sensor value, we get a number that we call the error. Let's calculate the error and store it in a variable. So to summarize, if the error is positive, this means the car is to the right of the track, and the size of the error tells us how far to the right we are from the track. If the error is negative, the car is to the left of the track, and the size of the error tells us how far to the left we are from the track. If the error is 0, we are exactly on the track. Now, given the error, how should we steer? We want the car to be exactly on the track, so we should steer in such a way that the error becomes 0. If the error is positive, we are to the right of the track, and thus we need to steer to the left. As we saw earlier, we need to output a positive steering angle to achieve this. Also, the more positive the error is, the more we want to steer to the left, or the bigger we want the steering angle to be. We can reach this goal by making the steering angle equal to the error but multiplied by some constant p. We will later find a good value for p, but let's set it to 1 for now. Mathematicians would say we made the steering angle proportional to the error value. So now you know why we call this a proportional controller. Okay, I think we're ready to test. Let's put the engine torque to 800 Newton meters, click practice and see what happens. This seems to work, but you can see the car steering rapidly from left to right. This is probably because we chose P too large. Let's try to set it to 0.1 and see what happens then. Okay, it steered a bit to the right, but then lost the track completely. This is because we are not steering aggressively enough, or P is too low. Let's try to set it to 0.25. This seems to do the trick. We just built a self-driving race car. Congratulations! There are many ways to make your car go around the track faster. You can try to go faster on the straights and slower in the corners. Just make sure you don't crash the car. Once you are ready with your design, push the compete button and we will measure how long it takes you to finish 3 laps. This time will be put in our ranking tables, where you can compare yourself to the other roboton-io users and see who is king of the track. That was it. Have fun, and I'll see you next time.